Hi there, it's Mrs. Tellas. We're going to do section 3.3 here. 3.3 is about functions. So we'll be solving them, evaluating them at particular numbers, interpreting them, graphing them. Okay. So function notation is the same. Y and f of x are the same thing. So when we have the equation y equals 3x minus 8, which is linear, we can write that also as f of x equals 3x minus 8. These two are like synonyms in English. They mean the same thing. And function notation is just a helpful way of plugging things in for y. So if we have this function here, f of x equals 2x minus 7, and we're going to plug in x, we're going to plug in 4 for x. So we're going to put 4 in right there. So 2 times 4 minus 7 is 1. Okay, so you can write it as when I evaluate f of x at 4, I get 1, or you can just write 1. Either way. Same thing for negative 4. I'm going to put it in there. 2 times negative 4 minus 7. So that's negative 15, and you can stick that right in your calculator. All right, press pause and try those bottom 3 problems. You're going to take the negative 4, the 0, and the 3 and put them in separately. So it's 3 separate problems. See if you get those right. All right, so let's plug in the negative 4. So I'm putting it right in there. So negative 4 minus 1. See, that'd be a positive, so that's 3. If I put the 0 in there, negative 0 minus 1 is negative 1. And if we put the 3 in there, negative 3 minus 1 is negative 4. So if you got those right, good job. They're just plug-in chugs. That's all they are. All right, so this one's a little harder just because you have to interpret. You have to read what the directions say, and then you have to figure out what this means down here. There's not really any math. It's you figuring out what it means. So it says, let f of t be the outside temperature, T, hours after 10 a.m. Okay, so this over here is our temperature. This side is our temperature because f of t is the outside temperature. The 0 here is based on particular hours after 10 o'clock in the morning, 10 a.m. Okay, so this first one says that it's at 75 degrees at 10 o'clock in the morning because the 0 hour is 10 a.m. Okay, so you can see here on this one, it's n degrees at 3 hours past the 10 o'clock. So if it's 10 o'clock and I add an hour, that's 11. I add 2 hours, that's 12 noon. And I add another hour, that's 1. So at 1 p.m., it's n degrees. Okay, and then here it says at 11 o'clock, it's the temperature outside is hotter or greater than the temperature at, let's see, we already started it up here. We're at 3. So 4, 5, 6, 7, 8. So at 6 p.m. the temperature is hotter. We don't know what the temperature is. We just know at 6 p.m. it's hotter than at 11 p.m. So the number inside is how many hours away from 10 a.m. it is. The number on the right is the temperature outside. So why don't you press pause? Do I have another one of these? I do have one. Can you try this one back here? I'd like you to press pause and give this a try. So it says your height in inches can be represented by the function h, where the input is your age. So explain what h of 14 equals 72 represents. Try that. Press pause and try that. And explain what h of 15 is less than h of 21, what that represents. Okay, push pause and give those a try. I know they're hard. I'm aware. Okay, I want you to try. All right, so if we try these together, it says your height in inches can be represented by the function h, where the input is your age. So the input is what we input right there, because the function would be h of x equals your height. Okay, and this right here, the x is going to be your age. So this says when you're 14 years old, you're 72 inches tall, or can't be 72 feet, it has to be inches. Okay, and here it says you're taller when you're 21 than you are when you're 15. It doesn't say how tall we are. It just says your height when you're 15 is less than your height when you're 21. Okay, so if you got those, you understand. And if you don't, there's more in the book to practice. Okay, when we do our assignment. All right, let's go back to this thing. All right, so we're back at plugging in. All right, notice that this is different. We have a function here, and I know I had a fraction in it. That's not what's different about it, though. Notice that it doesn't say f of 4. It says g of x equals -4. So what that means is I take the g of x out right here, and I put -4 in its spot. So it's a little bit of a different plug. So -4 equals 1/3 x minus 2. So I use my solving skills from chapter 1 and add 2 to both sides. And then I'm going to multiply by the reciprocal. So that's -6 equals x. Do you understand? Okay, so I hope you do. So the difference here says that you're taking the g of x out and putting the -4 in. If it was written the other way, it would say g of -4, and then you would take the -4 and put it in there for x. They're completely different problems. Okay, so you try this one. Here's your function, h of x equals 6x plus 9. This says you're taking the h of x out and you're putting 21 in its place. So 21 equals 6x plus 9. So I subtract 9 and divide 6. So my answer is 2. Okay, if it wanted me to put the 21 right here, it would have said h of 21. And then I would have plugged the 21 in, 6 times 21 plus 9. But that's not what it asked me for. It asked me to take the 21 and put it in here for h of x. I hope you see the difference. All right, so we're going to make a table. We did this a little bit in 3-2. So this shouldn't be too terribly new. All right, f of x equals 2x plus 5. That is the exact same as y equals 2x plus 5. So for my domain or my x, I'm just going to use 0, 1, and 2 because it's easy math. It makes for easy math. So if I put in 2 times 0 plus 5, that's 5 for y. And 2 times 1 plus 5, that's 7 for y. And 2 times 2 plus 5, that is 9 for y. So I can write the points out, or I can just read the table. So 0, 5 would be up 5. 1, 2, 3, 4, 5. 1, 7 would be right 1 and up 7. 2, 9 would be right 2 and up 9. And that's what my picture looks like. Okay? All right. Press pause and you try this one. It's exactly the same thing. Use 0, 1, and 2 again. Okay, and get it graphed on a piece of graph paper, or you can freehand it on your paper that you're using. So if we make a table, 3 minus x, and remember this is the exact same thing as this. It's no different. It's not in slope-intercept form, but it's close. Right? So if we use 0, 1, and 2, that'd be 3 minus 0. 3 minus 1 is 2. 3 minus 2 is 1. So I'm just going to take these points and plot them. So 0, 3 would be up 3, right 1 and up 2, right 2 and up 1. So this has got a negative slope. So if you got that right, good job. Very good. All right, so these are in your book, and I think they're important. So it says, find the value of x so that f of x equals -2. Well, that's the same as y equals -2. So I go to the graph, and I look for y, which is the up and down, and -2, which is right there. Well, at this point, what is the x value? Well, the x is 0. Because look, if I go up, the x is right here. This point is 0, -2. So when y is -2, so x is 0. Okay, so let's do the next one. Same thing. So it says, find the value of x so that f of x equals 3. Well, that's the same as y equals 3. So I want to know the point where y is 3. So I go up to 3, 1, 2, 3, and I go over right here. Well, whatever this point is going sideways is my x. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 is the answer. Okay, press pause and you try the last one. It says find the value of x so that f of x equals -4. That's the same as y equals -4. Okay, give it a try by yourself. Okay, so if I go to y equals -4, 1, 2, 3, whoopsie, 1, 2, 3, 4, I actually have two answers. My x would be here. We'll go with -1 there. And here, about halfway between, let's see, 10, 9, 8, 7. So between -7 and -8. Okay, so you've got two answers on the parabola here. -1 and we'll just go with -7.5. So there's two x's there. All right, last one. So light travels 186,000 miles per second. The d of t, or the distance, equals 186,000 t, gives the distance d of t in miles that light travels in t seconds. So d of t stands for distance, and t stands for seconds. So I'm going to use this equation right here, and they're going to give me either the distance or the time, and I got to read which one it is. So how far does light travel in 30 seconds? Well, this is t. So I take my 30 and I put it in for t. So 186,000 times 3. I don't know what that is. Actually, I think I have it under here. Let's see. Oop. Yep, there it is. 5,580,000 miles. Okay, so all I did was take the 30, not 3, and plug it in for t. And then if I go down here, I'm going to use the same formula. This time I'm getting 3,720,000 miles. Well, distance is d of t, so it goes in on this side, and the other side is the same. So 1860 t. Is that the right number? Yes. So I'm going to divide both sides by 186,000. So these are just plug and check. They're very similar to this first one. It just has content or context. So this is 20 seconds. T is 20 seconds. So I hope you're doing okay on functions. You're going to try that big ideas assignment that goes with this lesson. So you're going to type the answers into big idea, and then you'll submit your work on Canvas. On the graphs, you can use graph paper if you have it, or you can just do a freehand graph. Either way, it's totally fine. So, okay, thank you very much and have a great day. Bye.